Hey everybody, it's Mr. N here, and we've got the 1-4 lesson from our Big Ideas book, and this is on perimeter and area. Well, before we do that, let's define what a polygon is, and a polygon just means many angles. So breaking down the definition, the poly is many, and the gon is with the angles. So the definition here, for technical purposes, says each segment intersects exactly two other segments, one at each endpoint, and no two segments with a common endpoint are collinear. What that means is if I start drawing this out, I'll have one segment and it intersects exactly two other segments, so that means I'll have another segment like this. This segment will have another segment like that. So each of these, and if I can close it out like that, each of these segments will have two other segments, 1 and 2, if I'm talking about this one, attached to it, and no two segments with a common endpoint will be collinear. So here's how your book ends up defining it, and it's pretty much the same thing. And then we have this piece right here, which is called a diagonal. And when we deal with a diagonal, I'll get into that in a little bit as far as a little bit more detail. We are connecting non-consecutive vertices. So I wouldn't connect it from B to C because that's a consecutive vertice. I would go from B to D. I could go from B to E. Then we've got sides here that make up my polygon, and each of these points will be a vertex, so these will all be vertices. Then we've got something that's called convex, and convex simply means a polygon such that no line containing a side of a polygon contains a point that is in the interior of the polygon. So here's how I kind of like to instead say something is convex. It's convex if you can draw these diagonals and they never are on the outside. They are always inside of the polygon, then it's going to be convex. Concave would mean somewhere in the polygon it would cave in on itself. So imagine if I connected these two diagonals, and I'll do this in this color right here. If I connected, see how those two, if I connect, I'm sorry, these two vertices with a diagonal, see how that diagonal is on the outside of the polygon? Well, that would make it concave. So we say that it somewhere in here it caves in on itself. I'm going to use a different pointer for this one. So somewhere in here it'll cave in on itself, and that's what's happening. And we've got the interior. So again, the way I described it, if any part of the diagonal contains points in the exterior of the polygon. So whenever I draw a diagonal, if anywhere on here I draw a diagonal, I end up on the outside, we're going to say it's concave. It caves in on itself at some point. And then to recap, we said a diagonal is a segment that joins two non-consecutive vertices. All right, let's move on to this next page of notes. I'm going to scroll this down a little bit. And then we can name a polygon by the number of sides it has. And we can go back to the lightsaber. And we'll do blue. Actually, let's do red this time. And we could say if it's 3 sides, it's a triangle. 4 sides, quadrilateral. 5, pentagon. 6, hexagon. 7, heptagon. Not a septagon or anything like that. Heptagon would be 7 sides. 8, octagon. 9, nonagon. And 10, decagon. 11, hendecagon. 12, dodecagon. 13, 14. 13, tridecagon. 14, tetradecagon. And then we have names for so many more, but we're just at that point, we're just going to say n-gon. In fact, for me personally, just go up to 10. Anything past that, you're going to say like an 11-gon, a 12-gon, a 34-gon means it's got 34 sides to it. But up to 10, for me, for my class, I want you guys to go ahead and just memorize those because those are just good to know. All right. In class, we're going to do these student journal examples that are on page 21 through 14. But for right now, for this video, I am going to do some examples for you, and I'm going to do these examples. So You don't have these, so if you want to write these on a separate piece of paper, pause, however you want to do it, but screenshot it, write it down, either way. But let's go ahead and do these for practice. In 1 and 2, classify the polygon by the number of sides, tell whether it's concave or convex. So this is 4 sides to it, so since it has 4 sides, this is a quadrilateral, and this is convex, because wherever I draw a diagonal, anywhere I draw, in fact there's only 2 diagonals, they're both going to be on the inside. This next one has 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. And since, look at, if I draw a diagonal between these two, it's on the outside. So anywhere I can find where I draw a diagonal, it's on the outside, it'll end up being concave. Another way to think about it is here it caves in on itself again. All right, for number 3, it says find the perimeter of a quadrilateral PQRS with these vertices. All right, so I'm going to move this up, and I'm going to do this down here so that we have a little bit more room, so I can draw an axis over here. And I'll just do this down here. And this is for number 3. And then let's plot some points. We've got the point 1, 2, 1, 2, 3, 4 right there. We've got the point 2, 3 right there. So this is P, there's Q. Then we've got the point -2 and -2. And then we've got, this is point R, and then we've got the point -2, positive 1, 2, 3 right there. Now, in order for me to find the perimeter, I'm going to need to find the lengths of these sides right there, and I can find the distances of each of them. Well, let's start with this one. This one is 1. That's easy. Let's start with these vertical ones. And on this one, I'm going from, this should have been a height of 3. And that's it. So this will be 5 right there. And now I need to find these diagonal pieces. These 2 diagonal pieces. Well, let's take these 2 pieces out. I'm going to take this first piece, little diagonal piece out right there, and I'm going to draw a right triangle out of that. It's this piece right here I'm taking out. Well, I know that this is 1, and going across I'm at -2, and I'm going all the way to +2. That's 4. So now I can use the Pythagorean theorem, which is the distance formula, same thing, and determine that this is going to be 4 squared plus 1 squared. So this will be the square root of 17 right in here. So far I've got 5 plus 1 plus the square root of 17. Now let's do the next one right here. And I'm going to take this out so you guys can see it a little bit better. And again, I'm going from -2 to +2, so that's a distance of 4. So from here, -2, all the way over to +2, that's a distance of 4. And I'm going from -2 all the way up to 3. So from -2 all the way up to 3, that's a distance of 5. So I end up with D right there, and I can use Pythagorean theorem. So D will be the square root of 16 plus 25, which is going to be the square root of 41. So that's added onto this. So this whole thing will be 6 plus the square root of 17 plus the square root of 41. If I asked you to do this as a decimal, you would change these to a decimal. But for now, I'm just going to keep them in square root form. All right, let's do the next one. Let's see if these are just as difficult. Find the area this time of the polygon. So let's go ahead and plot some of these and see what we got. We've got T being, let's choose a different color here. And T is being 0, -2. U being 1, 2, 3, 1, 2, 3, 4, 5. V as -3, 5, and that's it. We got those three right there. Okay, so this is -3, 5, and this one was 3, 5. So I can connect that, I can connect that, and I can connect that. So this length went from -3 all the way to 3, so this length is 6. And since this is 3 and that's 3, I know that this is cut in half because that vertex is at 0. So this is going to give me an isosceles triangle. So I know that this height right here is going to be 5 and then -2, so that'll be 7. So this height right in there will be 7. So the area of a triangle, reviewing from what we know, is 1/2 times the base times the height. So the area will be 1/2 times 6 times 7. So the area will be 3 times 7, which is 21 square units. All right, let's move on to number 5, and we'll plot that right here. And let's pick another color again. Let's go with this green, this shade of green. And we've got A at -1, 2, 3, +1, 2, 3. There's point A. We've got point B at -3, -1. We've got point C at 1, 2, 3, 4, -1. And we've got point D at 4, 3. So we end up with this rectangle that you see here. And we can find the area of this because I went from -3 and over here to 1, 2, 3, 4. So that's a length of 7. And I went from -1 in the y all the way up to 3 in the y. So that's a length of 4. So this is 4, and that's 7. They're both going to be like that. So the area is 4 times 7, and this will give me 28 square units. All right, hopefully that wasn't too bad with those examples. We're going to do more in class. Hopefully polygons won't be too bad, especially identifying concave, convex, and then remember, you only have to name them up to 10. So thanks for watching. Make sure to hit that like and subscribe button, and I'll see you guys in the next video.